Okay, so for sake of time, I'm gonna keep going just to see how many people have done it. Can you type in the chat who's done it and put your answer for B in example 4. You done? Okay. What did you get? What did you guys get for B? Okay, that's correct. 107 you got. Okay, let's see. Okay, so we had for B it was 23y, where y is equal to 9. So 23y and y is equal to 9. So we just open the parentheses to plug in 9, and 23 times 9 is 207. You didn't see that. So here in this calculator, 23 times 9 is 207. Go back to the paint. Okay, let's do example 4 really quickly. We had negative 2x minus y, negative 2x minus y, and x is equal to negative 5, and y is equal to negative 3. Negative 3. So negative 2, open parentheses, negative 3 goes here. Negative 5, we just plug in the variables. Negative 2 times negative 5, two negatives, so that's a positive 10. And we have this double negative again, double negative property, that's a positive, plus 3. And that is 13. So we have for number 4, the answer is 13. And for B, the answer is 207. This makes sense for everybody. Okay. I can't see a screen. Can I come? Yeah, you can go. You can leave. Makes sense. Okay, let's move on. So evaluation. So here's a word problem. Example number 9. The cost of a daily truck rental is $48 plus an additional 45 cents for each mile driven. This cost in dollars can be modeled by the formula cost equals 0.45x plus 48, where x represents the number of miles driven in one day. Use this formula to calculate the cost to rent the truck for a day and drive it 120 miles. So we have the formula. They gave it to us already. The cost of daily truck rental is $48. So we have 48 out here, and an additional 0.45 cents for each mile driven. So it's a decimal form. All you have to do is plug in 120 because you're trying to find out how much it costs whenever you drive that many miles. So here they did it for us. They plugged in 120, 0.45 times 120 is 54, and they add 48 is 102. So the rental costs $102. So here, again, we see the plugging in X for the value it's been assigned. Here are some word problem examples. You only have to do the example number 11, the second one. Did you finish it? Okay, yes, yeah, you finished it. Let me share a new screen. Okay, so we had a wooden box, 1 foot in length, 5 inches in width, and 6 inches in height. So you want to find it in cubic inches. So one 1 foot, 6 inches, and 5 inches. The answer is in cubic inches. So the first thing we need to do is get this feet to inches. So there are 12 inches in 1 feet. The second thing we need to do is write the equation. Can someone unmute their mic so that they can tell me the formula for volume? I don't want to choose someone in random. Your mic doesn't work. Okay, you're excused.
Base times height.
Base times height. But can you tell me what the base is?
Oh, the base?
Yeah.
72, because 6 times 12.
What's that? Can you speak louder?
72.
Okay. So you said base times height. That is correct. And the base is it's a rectangle. So we have the length times the width. So length times width times height is the volume. How you measure volume. So using this, we can plug in all these values. 12 times 6 times 5. Let me share this. So 12 times 6 times 5. And this is 360. So 360 inches cubed inches. Did this make sense for everybody? It made sense.
Yes.
So what we did was we found the formula for the volume of a box, length times width times height, and we plugged in all the values evaluated, and then we multiplied them and we got the volume. So let's move on to the next slide. Distributive property. The properties of real numbers are important. In particular, the distributive property states that any real number a, b, and c. So a parentheses b plus c equals ab plus ac. So what they did was they multiplied a times b and the addition symbol, then a times c. So inner and outer. Example number 1, simplify 5 parentheses 7y plus 2. So what they did here was they did the same thing. They multiplied 5 times 7y and 5 times 2, the inner and then the outer. So then they got 35y plus 10. Once they multiply 5 times 7, 35, 5 times 2, 10. And you can't, these are unlike terms. You can't combine them. Does this make sense? This property is important. A parentheses b plus c equals ab plus ac. So you're distributing the a to both the b and the c. Does this make sense? Yes. Okay, now we have some more practice. Simplify -3. This small 2 is squared. So it's 2x squared. plus 5x plus 1. So just distribute it, you know what to do. Okay, done. Okay, I'm gonna wait for Alvel to finish. Done. Okay, you finished? So let me share this. So we had this. This is what they gave us. To simplify, we distribute the negative 3 to 2x squared, then to 5x, then all the way to 1. So the negative 3, you multiply it by 2x squared. Again, we have negative 3, multiply it by 5x, and then negative 3 times 1. So negative 3, you just multiply the coefficient with negative 3. Negative 3 times 2 is negative 6, x squared. Negative 3 times 5 is negative 15, x. And negative 3 times 1 is negative 3. So this is fully simplified using the distributive property. Can't simplify it anymore. These are different terms. That's it. Okay, let's move on. Any questions about this problem? If there's no questions, I'll move on. Okay, division in algebra is often indicated using the fraction bar rather than the symbol, the division symbol you're accustomed to. And sometimes it is useful to rewrite expressions involving division as products. So here we have x over 5 equals 1, yes. Okay, so we have x over 5 equals 1x over 5, and this is equal to 1 over 5 times x. So you can break apart the x over 5 and make it into 1 over 5 times x. So we have 3ab over 7. This is equal to 3 over 7 times ab over 1. ab over 1 is the same thing as ab, and we can take out the 3 over 7 from this expression right here and make it 3 over 7 times ab. And the last thing we see here is x plus y over 3 is the same thing as 1 over 3 times x plus y. So we can take out the 1/3 from the bottom and make it into a fraction and then distribute it. By rewriting the algebraic expressions as products, 1 over 3, it allows us to apply the distributive property. So now we can do the inner and outer thing. Does this slide make sense before I go to an example of using this? Good. Example of using division. So we have a example here, 25x squared minus 5x plus 10 divided by 5. So again, we can take out the 5 here from the bottom, make it into a fraction, 1 over 5 times 25x squared minus 5x plus 10. Now, all we're left to do is distribute 1 over 5 times 25x squared. 1 over 5 times negative 5x, and 1 over 5 plus times 10. So then we just multiply the coefficients here, 5x squared. Then here we have negative x, and here we have 2. So by rewriting the algebraic expression, taking out the 1/5, you're able to simplify it and distribute. This makes sense. So here's an example of using the just the thumbs up reaction if you're able to. Yeah. Combining like terms. So earlier we defined the term as here. We defined the term as this is a term 2x, so, and then this is another term 3. They're separated by addition operators. So going back here, we have another term. They're separated by addition operators, so subtraction operators. But like terms they have the same variable parts. So 2a and 3a have the same variable parts a, and because these terms are similar, you're able to apply the distributive property and add them together. So we have 2a plus 3a. You're able to put 2 plus 3 in parentheses and a on the outside, because whenever you distribute the a's, 3a plus 2a, as you see over here, then you're just able to add the whatever's in the parentheses because of PEMDAS, and you have 5a. Same thing with 7xy minus 5xy. You put the 7 minus 5 in the parentheses, and you're able to get 2xy. So you're just applying the addition, you're applying the operation to the coefficients. 7 minus 5 is 2. Okay, here we have x squared, x squared, x squared. These are all like terms. You're able to apply the operations to the coefficients. 10 plus 4, 14, 14 minus 6, 8. So 8x squared. This process is called combining like terms, when the variable parts are exactly the same. Does this make sense? We're going to do practice on this. All you're doing is adding the coefficients if the variable parts are the same. Okay. Combining like terms practice. Just do example 6 for sake of time. Simplify 3a plus 2b minus 4a plus 9b. So rearrange it and identify the like terms. And done. Okay. So let's review this. Share the screen. Okay. So this is what we're given to simplify. The first step is to rearrange the equation to bring the like terms together. So like A, these are like terms. B, these are like terms. So we can rearrange the equation to bring the like terms together. So now that we have the like terms together, we can do the distributive property. We can apply the distributive property. We do whatever's inside the parentheses first. 3 minus 4 is negative 1. So we have negative a. And 2 plus 9 is 11, so we have 11b. So this is the answer that should have got, combining the like terms. All right. Distributing positives and negatives. So whenever you have a positive, you distribute the positive to A and to B. So you end up with AB at the end. Whenever you have a negative, you also distribute just like the positive to A and B. So it's -1 times A and -1 times B. So then you get negative A minus B at the end. These are two useful properties that will come in use later. Remember this one on the bottom, negative A plus B equals negative A minus B. Whenever you distribute the negatives to the inner and the outer. Does this make sense? You're distributing negatives.
Yes.
Distributive property and like terms. So when simplifying, we will often have to combine terms after we apply the distributive property. This step is consistent with the order of operations, multiplication before addition. So example 11, we're given this algebraic expression and we're supposed to simplify it. So we have 2 on the outside and we're supposed to distribute it to 3a and negative b, as well as -7. This isn't a minus, this is a -7 together, and then you have to distribute this also. 2 times 3a, 6a, 2 times 2 times b, 2 times negative b is -2 times b, same thing. And then we have -7 times -2a, then -7 times 3b. Simplify like terms, you add the like terms together, and you get 28 minus 23b. Okay. I trust that you got it. So watch out common mistakes. One common mistake you can make is forgetting the order of operations whenever you see something like this. The incorrect way to do it is 5 minus 2 first, and you get 3. And you get, then you distribute the 3, you get 3x squared minus 12x minus 9. That's incorrect. Always, remember PEMDAS, you do multiplication first instead of addition and subtraction. So the -2 is supposed to be distributed to x squared and -4x and minus 3 to get -2x squared plus 8x plus 6. Then you add the 5 to the 6 and you get 11. So this is the correct way to do it. Remember PEMDAS whenever you see something like this. It's a common mistake. Solving linear equations. So a linear equation is any equation in the general form ax plus b equals 0, where a and b are real numbers and a is not equal to 0. All of these are linear equations. X plus 3 equals -5, 2x minus 5 equals 15, and so on. So the solution to a linear equation is any value that can replace the variable to produce a true statement. So for this equation, the answer is x equals 5. To prove that this is correct, you can substitute 5 in for x, and it should give you the same thing on the left-hand side and the right-hand side. And this is how you check your solution to linear equations. So is y equals -3 a solution to 2y minus 5 equals -y minus 4? Replace your variables with parentheses. You add the variable, the value that the variable is supposed to represent inside the parentheses, and then you simplify. If it's true, then this is a solution. If you get a different number, if they are not equal to each other, then this is not the solution. Properties of equality. These are properties of equality. You can use them to manipulate the equation whenever you're trying to solve for for the variable. So the goal is to develop a systematic process to find equivalent equations until the variable is isolated. The variable is by itself, as in this x equals 7. Due to this, use the properties of equality. So all these properties, you do the operation on the left-hand side as well as the right-hand side. Yes? Yes, I'll argue your host after this. Okay. So properties of equality. So if you have C, a real number, you add it on the right-hand side and the left-hand side. Same thing. Okay, I will. And the subtraction property of equality, you subtract the number on the left-hand side as well as the right-hand side. Same thing with the multiplication property. Whenever you're trying to multiply something, you do it on the left-hand side and the right-hand side, and the same works with division. How to solve linear equations in 2 steps. So the goal always is to isolate the variable. The first, you use the appropriate equality of addition or subtraction to isolate the variable term. Over here, you're trying to isolate the variable x. So they subtract 3 to cancel this out on both sides. Subtraction property of equality. So they subtract on both sides. The 3's canceled out. Next, isolate the variable using equality property of multiplication or division. So there's no coefficient, so you don't have to use this equality of multiplication or division. So x is just equal to -8. But we have an example that you need to use the multiplication property. Over here, we have a coefficient after we use the addition property of equality. So we added 5 on both sides to cancel out the -5, and we isolated the variable. So 15 plus 5 is 20. So now we have a coefficient on 2. To isolate x completely, we use the division property of equality. We cancel out the 2. So divide 2 on the left-hand side as well as the right-hand side. The 2's cancel out. You get x. And 20 divided by 2 is 10. This is another example that shows this property too. And if this made sense for everybody, then I'm going to do practice. This is the last practice, so I give you a few minutes to do this. Are you finished already? Did you finish both of them? Okay, very good. We're just going to be waiting for the other people. Okay, you're done. Everybody else? Alba, are you done?
Hold on.
Okay. I'll give you another minute. Okay, for the sake of time, I'm just gonna do the first one.
I'm done.
Okay, you're done. Okay, good. Okay, so number one, we have 6 minus 5y equals negative 14. The variable here is y, so our goal is to isolate this variable. So use the the subtraction property of equality. We subtract 6 on both sides. So the 6 cancels out, and we're left with 5y on this side. And the negative 14 minus 6, you're going to the left 6, so you have negative 20. Now we're going to use we're trying to isolate y now, so we're going to use the division property of equality. Divide 5 on both sides. Negative 5's cancel out, we're left with y. And negative 20, negative divided by negative is a positive, and 20 divided by 5 is 4. So the answer is y equals 4. Here we have 3x plus 1 over 2 equals 2 over 3. So we have fractions here. You can do it multiple ways. You can subtract 1 over 2, but I prefer to get rid of the fractions first. So you find the least common denominator. Over here it's 6, because you have 2 and 3. 2 times 3 is 6. So you multiply the whole thing by 6. Use the distribution. So 6 times 2 over 3, numerator by numerator, denominator by denominator. 6 times 2 is 12. 12 over 3 is 4. Again, we have here, we just distribute 6. 6 times 1 is 6, and 1 times 2 is 2. 6 divided by 2 is 3. And lastly, we distribute it to the variable. Okay, it's almost done. So 6 times 3x is 18x. So then we use the subtraction property of equality. You subtract 3 on both sides. The 3's cancel out. You're left with 18x equals 1. Then we use the division property of equality. You divide 18 on both sides. 18 cancels out. X equals 1 over 18. Okay, guys, that's it. Thank you for joining. Make sure to tune in on Tuesday. Next time I'll try to start at 12 instead of 1. Okay, that's it. Bye. Let me transfer the host to Yodi.
Hi, ሰላም እንደምናችሁ? Hello. ናችሁ?